A million times I've asked you, and then I ask you over again. You only answer, perhaps, perhaps, perhaps.
So, welcome everybody to this new episode of PhD Cafe. Today we are in company of Ekram. Thank you very much, Ekram, for being the new, not PhD student, but postdoc to be interviewed at PhD Cafe.
Well, thank you very much for inviting.
So, Ekram, you are an analytical chemist. What is exactly the job of an analytical chemist?
Analytical chemist is basically you do very fundamental level of research. For example, instead of an organic chemist mixing A and B and producing C, you study why A and B made C instead of a D. So that is the job of an analytical chemist.
So basically, instead to synthesize molecule, you want to find a way to analyze them, breaking them, and because that's a fundamental tool in research to understand with what we are working. With which instrument you are generally working?
I'm generally working with mass spectrometer.
What is exactly a mass spectrometry?
Mass spectrometry is when you have a bunch of molecules, you get it in the gas phase. It's not in a test tube, it's in the gas phase. And you put them in a motion in a linear line. And depending on their mass, after a certain time, they separate. So higher mass lags behind and the lighter mass moves forward. So you have got different cluster of ions depending on their mass. And that's how you detect them.
So the game of the PhD Cafe is that we are going to take your research, everything that you are telling us, and we are going to cut it in small pieces that are understandable by everybody. Don't worry, it doesn't hurt, and it's quite funny. So the first question, you mentioned that you are going to put in gas phases, but this perhaps is still too complicated. What we want to know is this instrument you are using, what give to you as a final data, and how you analyze it. How you can say, okay, that's the molecule that I'm looking for, that's the molecule, and it's not another one.
I see. So mass spectrometry is an instrument that has its advantages as well as its drawback. For example, advantages is, so take it this very crude example. I am wearing a black shirt and I'm 5'5". So mass spectrometry will tell you that this is a 5'5" black t-shirt wearing man. It doesn't tell you whether it is me, Ekram, or it is someone called James. So what happens, for example, say, take my hand as an example. Mass spectrometry will give you the weight of my hand. It's not going to tell you whether my hand is like this or it's like this. It's not going to give you the confirmation. It's only going to tell you the mass. It's only going to give you the weight.
You gave a great example, and this is the way in which we want to run PhD Cafe, because that's the really simplify things. However, it doesn't tell you if it's closed or open hand, but it's an instrument which, together with other instruments, can give you a total overview of the molecule you're looking in. So now we continue the game, and we are going to see, we are lucky because we are in a conference actually, and this is the poster of Ekram. Yep. So is working with a certain molecule called peptide. So can you tell us what peptides are?
Yes. So protein is a big part of our body. Like you eat meat, that's a protein. And basically what protein is, it's a long chain of amino acids. And amino acid is basically a bond, which is basically, if you look closely, is this CONH2 bond. That's the amide bond. And when you get this long, like you get 100 of them in chain, you call them amino acid. So what peptides are? So for example, when you get 10 or 15 amino acids, you call them peptide. And peptide are an isomer of that. So what happens in a peptide is, if you look over here, this is the structure of a peptide, and you have got an R group at the nitrogen N. If you take this,
I need to stop you a second because we are going to do this game of successive simplification. So now you use words like peptides, peptoids, amino acids. What we have to say is that, okay, is showing for most of the people looking at this video, they don't understand what these drawing are.
I'll give you an easier example.
Oh, go on.
Okay, so suppose I'm standing here with my hats on over here. Okay, so that's one of my configuration. I take my hats off and put it on my hand. I'm still me, because if you wear me, it's still going to be the same whether I put my hats on over here or put my hand over there. But they are two different configuration. So peptoid and peptides are just like that. They have the same mass, but they have a different configuration.
So peptoids are mimetic of peptides, and so why you are studying an analytical method for peptoids? It's not comparable with peptides?
No, it is comparable, but it has differences. So, for example, peptides are ubiquitous in everywhere. Peptoids are not unnatural; they are natural. They are inside our body. For example, inside the lungs, the inner wall of the lungs are protected by peptoids, and that's the part where your body is exposed to the atmosphere. So peptoids are very important, but there are certain, because of that change in conformation, there are certain behavioral differences in peptoids and peptides. For example, if you take peptide inside your body, if you eat a peptide, it's going to get digested. If you eat a peptoid, it's not going to get digested. So there is a difference, and then that difference is why we study peptoids in molecular level.
Okay. So basically, the peptoids are mimetic of peptides. We are interested in study them because to use them as drugs and as with other function, because they can be similar but enough different to have properties to be used in different ways. And what you are giving to the research is a method, analytical method to study these molecules.
Yes. Yes.
Okay. So that's the impact of your research in this field.
Yeah.
And so I thank you a lot. Before to stop, actually, wait, don't stop. I have the art director, which is after I have to put the credits for the help. So we want to know also a little bit more about you, Ekram. So you are in US, but you are from?
I'm from India.
Where from India?
In the eastern part, the state is called West Bengal.
Okay. And you are here since a long time?
Yes, I'm here since 2006.
Okay, cool. And can I ask you something?
Yes.
It's a little bit tricky, but it's interesting for PhDcafe. I would like that you can resume in really few words your research or the interest you have in your research in your native language.
In my native language?
Exactly, because one other proposal of PhDcafe is that everybody in the world can use this hashtag to communicate science in their own language. Me, I can do it only in English or in Italian or in French, but other people can do it in many other languages. So we start to give the example. You don't have to say everything we said, but you can say really shortly why you are interested in doing this study, why you like science, what is everything about in short.
Few things.
Yeah.
I speak two languages. Back in India, there are lots of languages. Yeah. So there is one national language and there is one state language. So I don't know which one you want me to do. And second of all,
the one you feel more comfortable with.
Okay. I have not spoken in either of those languages for like 8 years. And the other thing, there are many terms which are not even existing in those languages.
Yeah, that's why we want that everybody can express science in different languages, because we know that for science, English is the best way because we can all communicate between us. But for making science become pop, we need to communicate in all the languages. And if we lose the vocabulary of science in any language, then it's tough for society. Mm-hmm. So if there are some words you cannot express in Indian, you can use English. Okay. But you have to try to do it in what is actually the language you are?
Bengali.
That's perfect.
My state language.
Perfect. The worst things can happen that they will make fun of your Bengali. But don't worry, the people which not speak of Bengali will not understand it. Okay, go on. You have 1 minute.
আমি এখানে পেপটাইড ফ্র্যাগমেন্টেশন উপরে রিসার্চ করছি মাস স্পেকট্রোমেট্রি ইউজ করে। পেপটয়েড হচ্ছে পেপটাইডের কনফরমেশনাল যমজ ভাই। জাস্ট আর গ্রুপটাকে অ্যামাইডের নাইট্রোজেন থেকে যদি কার্বনে সরিয়ে দাও পেপটাইড, তাহলে পেপটয়েড পাবে। আর আমরা এখানে ইউজ করছি লিথিয়াম মেটাল ইউজ করে পেপটাইডকে, যেভাবে পেপটাইডের ডিফারেন্ট ফ্র্যাগমেন্টেশন পাওয়া যায় মাস স্পেকট্রোমেট্রিতে, সে একইভাবে পেপটয়েডেরও ডিফারেন্ট ফ্র্যাগমেন্টেশন পাওয়া যাচ্ছে মাস স্পেকট্রোমেট্রিতে। কিন্তু পেপটাইডের একটা বড় লাইব্রেরি আছে যেখানে আননোন পেপটাইডকে ম্যাচ করানো যায়, কিন্তু পেপটয়েডের জন্য কোনো লাইব্রেরি নেই। আমরা চেষ্টা করছি যে পেপটয়েড কীভাবে ভাঙে সেটাকে তার মেকানিজম এস্টাবলিশ করার জন্য, যাতে আমরা একটা সফটওয়্যার বানাতে পারি যাতে আননোন পেপটাইড কীভাবে ভাঙে আমরা প্রেডিক্ট করতে পারি।
Okay, it was awesome. I didn't understand anything, but it was great. Thank you very much, Ekram. It was great.
Thank you.
See you at the next video. If you like the video, put a like and subscribe to the channel, and see you to the next episode. Bye.
Perhaps, perhaps, perhaps.